So welcome back, and in today's video we are going to look at a nice concept called upcasting and downcasting. What is upcasting and what is downcasting? So we saw what is casting, whereby you had a double, this is number, let me say 4.5. You wanted to change this num to another data type, whereby you had something like an integer, which is num2, which is equal to num. You can see that this won't allow, because you are saying that num here up is a double and it is having a decimal point, yet an integer is just a whole number. So Java is telling you that you might lose this 5 here, but for us we already want to lose it, we want 4. So what I'll do, I'll cast this, or I'll change this type. I will say this is not a double, this is an integer. So automatically after doing that, you will see that I have changed my data type from a double to an integer. So when I run this and compile, Java demo.java, run and compile, you will see that I'm able to access 4. Yeah, so that's typecasting. So today we're going to look at something interesting, and we are going to deal with classes. We are going to deal with something interesting called upcasting and downcasting. So let me say and we are going to keep it simple for learning purposes. Let me say I'm having class A and class B in this case. So class B can extend attributes of class A. Extend A. So inside here, I can create a method, void public, can make it public void show, which is just saying this is in A class. This method is in A class. I'll do the same thing for B. So I can come down here. I'm going to first explain what is upcasting. Upcasting simply means implicit typecasting, whereby this is done by Java automatically. What I'm meaning is that this is our child class and this is our parent class, but you can change attributes, or you can access attributes of the parent class immediately. So that's called upcasting, whereby a child class or a subclass can have access to a parent class. So you can come here and say, I can do this manually, but even Java does it automatically. So what I can say is that this A is equal to object, which is this object is of object new instance, this B, something like this. So when I try to access, now here I'm trying to assign, this is our new instance that we have created for class B, but I'm trying to assign it attributes of class A, in this case this one. So this means that I can access, when I say object dot, I can access the show in A. Simply after calling the instance, I upcast it, or I change its attributes to A. Now this means that it is now very possible for me to access the attributes of the parent class. This is done by default. Java does this after using the extends, but I wanted to explain this a bit further, that you can assign types of A to a child class. A can be a parent class and B can be a subclass. So when I try to compile this and run, you see that I'm able to access, this is in B. Okay, this is in B. Oh, sorry, I have to change this. I don't want to do what we call method overriding. So instead here, Yeah, now here I can access this show. You can see that I have changed different methods. They have in different methods. So when I try to compile and run this again, you see that I'm able to access the method in A simply by doing this upcasting way of doing things. This is called implicit typecasting, whereby a child class can have types of a parent class. So what if, remember here we are going up from a child class going to the parent class, but what if I am in the parent class and I want to access attributes of the child class? You can see here down, when I come here and I say here down and I say, let me just change this to B, and you see, change this to A and try to access the display method in B. You can see this is not possible. I'm calling an instance of A and I want to access the display in B. You can see this is not possible. Java is saying no, this is not allowed. A parent class cannot access attributes of a child class just like that. So they have introduced another concept called explicit typecasting, whereby this is referred to as the downcasting, whereby we can have our parent class accessing attributes of our child class. So let me take this back, meaning what I will do here now, let us try explicit typecasting, whereby we can change attributes of class A, the parent class, to fit those ones of class B, which is our subclass. So I will say B, remember we are changing attributes or types of class A to B. So I'll say B is equal to object, which is remember this is now our parent class right now. So I'm going to change, this is object 2. I'm going to change this object or this class, this instance of class A, I'm going to change it to the instance of class B, something like this. This is, remember what we did previously, we changed our child class or our subclass to attributes or to types of class A. Now we want to do the opposite. This automatically changed to A. Now I want to change this A to back to B. So what I did is that I created here a new line here. This line simply, I'm calling attributes or I'm calling the type of class B. I'm assigning it a new variable, and here I'm doing what is called explicit typecasting, and I'm trying to change this object here. Remember, this is now the instance of class A back to B. So this means that I can now access the display, this display from class B. So I'll say object 2 dot, you can see that automatically now I can access, which wasn't up here. Remember here on display you cannot access a display after changing this to class B, because display is not anywhere in class A. So to do this, in order to access the display while creating an instance of class A, we had to change this class back to attributes of the child class. So when I run this, run and compile, you see that I'm able to, I can first remove this, run and compile, you see that I'm able to access the class B while using the instance of class A. I'm standing on class A, but I'm now able to access attributes of class B. It's like a parent already knowing how the child looks like before even being born. It is somewhat funny. So that's it for today. We have looked at upcasting and downcasting.